So good morning, everyone. Good evening. So today I'm going to talk about the 8085 microprocessor and the innovation that I did for the LED matrix interfacing. So I did the innovation in the case of like adding a delay in the LED matrix interface and reverse and mirror imaging the characters that were shown. This is the original opcode that was there for the LED matrix interface with the 8085 microprocessor. Now here the first opcode, two changes are made here, which I'll explain in the further slides. The two changes are made at the memory address at the address 2019 and 201C. This one. Okay. By the way, one thing, this 2019, this basically refers to the RLC mode, that is like rotate left circular. So it basically tells how the scanning of the scanning of each columns in the LED matrix happens. That basically refers to this. Yeah. So this is also the further part of the LED matrix only. This the data table. We use three characters to basically portray our images, A, B, and C. Now, the first innovation that I did for the LED matrix was reversing the hardware scan. So, what happens actually? Originally, the data that was fetched from the like originally the data that was fetched from the microprocessor, it was from the original left to right sequence only. So the A, B, and C were shown in the should be shown in the normal way only. But what I did was basically the plot that was finally scanned by the hardware that was done by the RLC code. So I changed it from RLC to RRC, and and it finally the plot was changed from left to right to right to left. So in this way, the scanning started from the right to left part, and the mirror images were shown. Now this helps a lot because generally what happens if we want to mirror image a character, we would have to start write the entire code from scratch, but instead of that, we could just reverse the sequence and we can easily get a mirror image for this. And the change that was made was the at 201907, which was for RLC, it was changed to 0F, which was for RRC. Now, the second innovation that was done was manipulating the multiplexing delay. Now, at the memory location 201C, so it started at 201B and then it was at 201C, we got this memory address 40. So at we changed this from 40 to 50 and then to 80. So what happens is that there is a timer that basically counts down from 40 to like 0. In this way, the CPU basically wastes the clock cycles so that it can implement a delay in our LED matrix interface. So I just increased that delay from like 40, then to 50, and then to 80, so that we can easily understand so we can easily see how that LED matrix is changing from one character to another. This is the summary of the changes that I did. So yeah, this is like the shift direction, the delay value, and the final visual result that we were able to get.
If we had like changed this 2019 part with 0f, we can see that we'll receive mirror images of the characters. Let's just proceed on with that. I have already made the changes. Yeah, so you can see that these are the like mirror images of the original characters, like A, B, and C are reversed and they are flipped as per their mirror images. Another part is that we can increase this 201B, the second portion 40 to, like we can increase this to basically increase the delay. I have made the changes. I have increased it from 40 to 50. Let's just see if there are any changes or not. We can see that the time has slowed down a bit, and the delay has increased for our display of characters. I have changed it from 50 to 80 now. You can see that the delay has increased a lot and the characters are showing at a very slow rate now. Yeah, thanks. That's all.
Okay, so we were able to see like what the changes were done, and we have the final conclusion and the key takeaways. So instead of basically like utilizing the software and hardware together, we can easily like make our tasks easier. Like in this case, we were able to change the execution flow, and then we were able to like simply rewrite the data structures. Apart from that, we were able to understand like different instructions, and it helps us to understand like the opcodes that were there in the code. And that's all for now. Thank you.